Space stores objects that make entire galaxies look like fragile shadows of light. Among them are black holes, whose mass is so monstrous that the space around them begins to distort at distances of thousands of light years. They are hidden in the depths of galaxies, absorbing stars, gas, and even light, turning the cores of galactic worlds into raging regions of hot plasma. Some of them have been dormant, motionless, for millions of years. Some wake up, and then begins a process that can change the fate of an entire space region. At the center of almost every major galaxy is a supermassive black hole. Their masses reach millions and billions of solar masses. But there are even rarer, monstrous objects, ultramassive black holes. Their mass exceeds tens of billions of suns. Such objects are found in the cores of ancient giant galaxies, hidden among huge clusters. The gravity of these monsters is so great that the stellar orbits near the center begin to move at colossal speeds, and the matter heats up to temperatures exceeding the heat of millions of stars.
When such a black hole begins to move through intergalactic space, it turns into a gravitational storm. The space ahead is shrinking. The orbits of objects are curved. Gas clouds stretch into luminous filaments thousands of light years long. Plasma streams collide with each other, giving rise to monstrous shock waves. Some supermassive black holes can be ejected from the centers of galaxies after the collision of two giant galactic nuclei. During the merger, black holes begin to rotate around each other. Space trembles. Gravitational waves travel through the universe. If the collision occurs asymmetrically, a powerful pulse is generated that can eject the resulting black hole away from the center of the galaxy at a speed of thousands of kilometers per second. Then, the journey through the void begins.
Such a black hole could carry around it the remnants of a collapsed galaxy, clouds of hot gas, star clusters, and a glowing disk of matter. From a distance, it looks like a moving source of blinding radiation. Huge jets burst out of the polar regions at almost the speed of light. They pierce intergalactic gas, leaving behind giant radio-emitting structures. If such an object approaches a star system, the consequences will begin long before the immediate approach. Gravity will begin to change the orbits of cometary clouds on the outskirts of the system. Billions of icy objects will break out of their ways and rush into the system. An era of continuous clashes will begin. Then the orbits of the planets will change. Some worlds will be thrown into the interstellar void. Some will collapse to their star. Some will collide with each other. Gravitational forces will turn a stable system into a chaotic vortex. But the real horror begins closer to the black hole.
Matter falling into its gravitational trap forms an accretion disk, a giant ring of hot gas. Temperatures in such disks reach millions of degrees. They emit X-rays of such power that the atmospheres of planets can be destroyed, even at great distances. If a black hole actively absorbs matter, relativistic jets arise, narrow beams of plasma ejected from the poles. These streams are capable of stretching for hundreds of thousands of light years. They are saturated with radiation and high-energy particles. The impact of such a jet into a region of the galaxy can stop the birth of new stars, burn away clouds of gas, and change the evolution of entire stellar regions. Some quasars, the brightest objects in the universe, are just such supermassive black holes in a state of monstrous absorption of matter. Their light is brighter than the light of entire galaxies. They are visible through billions of light years. In the early universe, quasars were especially common.
Back then, young galaxies collided with each other much more often, supplying giant black holes with inexhaustible streams of matter.
There are galaxies where the central black hole almost completely controls the processes inside the nucleus. The giant elliptical galaxy Messier 87 hides a black hole with a mass of billions of suns. It was its shadow that was first recorded using a global network of radio telescopes. A hot substance revolves around it, and a giant jet pierces space thousands of light years. At the core of the galaxy NGC 4889 is one of the most massive black holes known. Its mass is so enormous that the inner region of the galaxy is almost devoid of stars. Over billions of years, gravitational interactions have literally cleaned up the central regions. Even more mysterious are wandering black holes. Some of them can hide in the intergalactic void, emitting almost no light. They cannot be seen directly. They are detected only by the distortion of the light of distant objects or by flashes that occur during the destruction of randomly approaching stars.
When a star gets too close, tidal disruption begins. Gravity stretches the star into a stream of hot matter. This process is accompanied by a colossal burst of energy. Parts of the star are ejected into space, and the rest of the matter disappears beyond the event horizon. The event horizon is the boundary beyond which space curves so much that there is no way back. Even light is not able to leave this area. For the outer universe, everything that crosses this boundary disappears forever. Near a supermassive black hole, time begins to flow differently. Gravity slows it down. The light is distorted. Space turns into a deformed area where the usual geometry loses its meaning. The orbits of stars curve into complex trajectories. Some begin to orbit the black hole at tremendous speeds, emitting intense radiation. In the centers of active galaxies, regions appear whose brightness exceeds the light of billions of stars. Magnetic fields of incredible power are raging there. The particles accelerate almost to the speed of light. Cosmic rays pierce space, propagating through galaxies and intergalactic voids. If such a black hole passes near the nebula, the gas structures will be torn apart by gravity. Density waves will begin to compress individual areas, causing bursts of star formation. In other regions, the gas will be completely dispersed. Huge dark clouds will turn into chaotic streams of matter. If the object gets close to a dwarf galaxy, the consequences can be catastrophic. The stellar orbits will collapse. Some of the stars will be ejected into intergalactic space. The central regions of the galaxy can disappear completely. Sometimes after such encounters, only broken streams of stars remain, traces of ancient gravitational annihilation.
Traces of such processes are already observed in the universe. Some galaxies have long stellar tails that arose after destructive interactions. Some cores move unusually fast, as if they had been ejected by a powerful gravitational shock. Some quasars are far from the centers of galaxies, which may indicate wandering supermassive black holes. Intermediate black holes hiding inside globular clusters and dwarf galaxies are especially dangerous. They are more difficult to detect. They can move through galaxies almost imperceptibly, gradually destroying the stellar orbits around them. But the most enormous objects are associated with the ancient epoch of the early universe. Already a few 100 million years after the Big Bang, quasars with masses of billions of suns existed. Their origins remain one of the greatest mysteries of cosmology. It is possible that the first black holes arose from the collapse of giant primordial clouds of gas.
They may have been growing at a monstrous rate inside young galaxies. Some theories admit the existence of primordial black holes, which appeared in the first moments of the existence of the universe.
If such ancient giants are still lurking in the intergalactic void, they may be almost invisible. Without active absorption of matter, a black hole does not emit light. Space can be filled with sleeping gravitational monsters moving through darkness. When two supermassive black holes converge, one of the most grandiose processes in the universe begins. Their orbits are gradually decreasing. Space begins to oscillate under the influence of gravitational waves. In the final moments, the energy released by the system exceeds the luminosity of all the stars in the observable universe, although most of this energy does not go into the light, but into the ripples of space-time itself. After the collision, an even more massive black hole is born. Sometimes there is a gravitational pulse that throws the object away from the center of the galaxy. Sometimes a new black hole stays in the core and begins to absorb huge volumes of matter, turning the galaxy into an active quasar. There is a possibility that some galaxies have completely changed their structure due to the activity of central black holes. Powerful bursts of energy could stop star formation by pushing gas out of galaxies. As a result, giant elliptical galaxies became cold and almost dead, filled with ancient stars and vast empty regions. Even intergalactic clusters feel the influence of these objects. The hot gas inside the clusters is heated by jets of supermassive black holes. Giant cavities, tens of thousands of light years in size, appear. These regions are visible in the X-ray range as huge dark bubbles inside the hot gas of the clusters.
Some black holes rotate at almost maximum speed. The space around them begins to get carried away by rotation. This effect is called the capture of the frame of reference. The orbits of matter become unstable. Magnetic fields twist into monstrous spirals. It is these rapidly rotating black holes that are considered the sources of the most powerful space jets. Light near the event horizon is bent so much that rings of photons are formed, regions where light can orbit a black hole. The observed shadow becomes not the hole itself, but the boundary of the region from which the light is no longer able to get out. If an ultra-massive black hole passes close to the galaxy, the effects could be felt for millions of years. Gravitational perturbations will alter the motion of the stellar arms. Gas clouds will begin to collide. Star formation flares are activated. This will be followed by the destruction of the central regions. Some stars will be accelerated to enormous speeds and ejected as hypervelocity stars.
In the most extreme scenarios, a black hole is capable of swallowing the core of another galaxy. Gradually, the star streams will merge. The orbits will shuffle. A new, giant elliptical galaxy will emerge with an even more massive central monster. The cosmos seems quiet only from afar. In reality, galaxies are constantly colliding, tearing apart, engulfing each other, and changing under the influence of invisible gravity. Black holes remain the main architects of these processes. They don't just destroy, they change the structure of the universe, control the movement of gas, the birth of stars, and the evolution of galaxies. And somewhere in the bottomless darkness of intergalactic space, ancient supermassive black holes that left their galaxies billions of years ago may be moving, invisible, silent, almost elusive. Only the distortion of the light of distant objects and the rare flashes of destroyed stars betray the presence of these cosmic abysses, near which even galaxies turn into fragile shadows in the midst of endless darkness.
The intergalactic void seems to be almost absolute silence. At distances of millions of light years between galaxies, rarefied clouds of gas, remnants of ancient collisions, and invisible streams of dark matter are hidden.
But even these huge abysses can be disrupted by the movement of a supermassive black hole. As such an object passes through the intergalactic medium, a region of gravitational chaos begins to form around it. The gas slowly pulls towards the center. Long, red-hot traces of plasma appear. Magnetic fields are stretched into gigantic structures that look like cosmic lightning, thousands of light years long. Some astrophysical models allow for the existence of ancient black holes, the mass of which exceeds 100 billion suns. Such objects are almost impossible to explain by normal growth through gas absorption and collisions. Their origin may be related to the epoch of the first galaxies, when matter was evenly distributed and huge gas clouds collapsed almost directly, bypassing the stage of ordinary stars.
If such an object moves through a galaxy cluster, the structure of entire regions begins to slowly collapse. Gravity changes the trajectories of dwarf galaxies. Some of them begin to orbit the black hole as satellites. Others collide with each other. Inside the cluster, giant waves of hot gas appear, visible in the X-ray range. Around active supermassive black holes, there can be huge dust torus, rings of gas and dust tens of light years thick. They hide the inner areas from ordinary light, but X-rays and radio emissions still break through. Inside these regions, matter moves at near light speeds, colliding and heating up to extreme temperatures. Some galaxies turn into so-called radio galaxies. Their central black holes create giant jets that extend far beyond the galaxy itself. These structures may be larger than the entire stellar disk. Radio beams pierce intergalactic gas, forming huge luminous bubbles. Inside them, particles move at almost the speed of light.
Especially powerful processes occur in quasars. The accretion disk around the supermassive black hole begins to glow brighter than the entire galaxy. The gas falls inward at a tremendous speed. The inner regions of the disk become so hot that they emit harsh ultraviolet and X-ray radiation. Sometimes the brightness of a quasar changes in just a few days, although the size of these regions reaches billions of kilometers. Some quasars already existed when the universe was less than 1 billion years old. This means that supermassive black holes appeared incredibly quickly. Their growth remains one of the most mysterious problems in modern cosmology. If a wandering black hole passes through a gas cloud, a slow absorption of matter begins. The gas is pulled out in long spiral streams. A glowing disk appears. The space around begins to fill with high-energy radiation. Even a single wandering black hole can temporarily turn into a bright light source visible through vast distances.
Sometimes such objects can hide inside dwarf galaxies. These galaxies themselves are dim and difficult to observe, but at their centers there may be unexpectedly massive black holes. Some dwarf galaxies are already showing signs of active nuclei, despite their small size. There are also hypothetical primordial black holes. They could have arisen not from stars, but from density fluctuations in the first moments after the Big Bang. Some of them could have the mass of asteroids. Others have a mass of stars, or even more. If such objects exist, they may be part of dark matter. Small primordial black holes would gradually evaporate through Hawking radiation. According to this theory, black holes are not absolutely eternal. Quantum processes near the event horizon cause them to lose energy. The smaller the black hole, the faster the evaporation occurs. In the final moments, it can release a powerful burst of energy. But supermassive black holes evaporate incredibly slowly. The time of their existence is so huge that it exceeds the current age of the universe by incomparable values. They will survive the age of stars, the age of galaxies,
and even the gradual extinction of space. In the distant future, star systems will begin to be destroyed by gravitational interactions. Many planets will be ejected into interstellar space. The stars will gradually go out. There will be white dwarfs, neutron stars, and black holes. Over time, it is black holes that will become the main objects of the universe. Galaxies will change shape by then. The spiral arms will disappear. Frequent collisions of stellar orbits will turn galaxies into huge elliptical structures. The central supermassive black holes will continue to grow, absorbing the remnants of matter and colliding with each other.
Each merger will be accompanied by the emission of gravitational waves. Space will tremble from colossal cosmic collisions. After billions and trillions of years, many galaxies will merge into one giant structure with ultra-massive black holes at the center. But even these monstrous objects are not eternal. When the reserves of matter run out, the accretion disks will disappear. The jets will go out. Quasars will turn into dark, silent objects. Black holes will slowly wander through the cold, expanding universe. Sometimes two black holes will collide. Then there will be a final burst of gravitational energy. After merging, a new black hole can receive a powerful impulse and be ejected into the void, where there will be no more stars, gas, or light. Only absolute darkness and slow evaporation through quantum processes. Over incredible periods of time, even supermassive black holes will begin to disappear. Their mass will decrease extremely slowly. The Hawking radiation will become stronger as it decreases. The final moment of existence will turn into a brief burst of energy in the midst of a completely dark universe. After the disappearance of the last black holes, the cosmos will change completely. There will be no galaxies, no star clusters, no red-hot nebulae. The space will become almost empty. Rare particles will move through the endless cold darkness. But as long as the era of black holes continues, the universe remains a place of gigantic catastrophes. In its depths, galaxies collide and tear apart. Stars disappear into accretion disks. Jets penetrate intergalactic space. Gravitational waves travel billions of light years away.
And among these processes, there may be objects that have not yet been discovered. Ancient wandering black holes that left their galaxies long before the formation of modern stellar structures. They move through space almost invisibly, surrounded by warped space and the remnants of destroyed systems. Sometimes their presence betrays only the strange motion of distant stars. Sometimes it is a sudden flash of a destroyed star. Sometimes it is an unusual curvature of light against the background of distant galaxies. And somewhere in the depths of the universe, a giant black hole may already be moving, whose mass exceeds everything known to modern astronomy. Without light, no sound, no traces.
Only gravity, only darkness, only the endless fall of matter into the region from which nothing ever returns. And while galaxies continue to spin slowly in the bottomless darkness, while the light of ancient quasars crosses billions of light years, the invisible movement of black holes continues in the depths of space. Ancient objects that survived the birth of star systems, the collision of galaxies, and the epoch of the red-hot young universe. Some of them have long since left their galaxies. After monstrous collisions, they were thrown into the intergalactic void and are now moving through absolute darkness. There is almost no light around them. Only rare clouds of gas begin to slowly swirl under the influence of colossal gravity. Space is curved.
The light of distant galaxies is deformed. Even the very fabric of the universe changes shape next to these objects.
Sometimes, such a black hole passes through the remains of an ancient nebula. The gas flashes with an X-ray glow. Shock waves thousands of light years in size are born. Magnetic fields are stretched into giant spirals. The particles accelerate to almost the speed of light and are carried away into the void, turning the silent cosmos into a raging stream of energy. But the black hole itself remains invisible. No light, not a surface. Only the area where stars, matter, and time itself disappear. In the deepest regions of the universe, objects with a mass exceeding billions of suns may be hidden. They drift slowly among rare intergalactic gas, surrounded by curved space. They cannot be seen directly. They manifest themselves only when a star, a gas cloud, or an entire galaxy is nearby.
Then, the destruction begins. Stellar orbits break down. The galactic arms stretch into gigantic, luminous streams. Clouds of gas collide and flare up with new stars. The central regions of galaxies heat up to monstrous temperatures. Jets, hundreds of thousands of light years long, appear, piercing intergalactic space with plasma flows. And all this creates an object that cannot be seen directly. Only consequences. Only a shadow among the light of galaxies. Only curvature of space. Even trillions of years from now, black holes will remain the last giants of the dying universe. When the last stars go out and the galaxies disappear, they will continue to move through cold space. Huge, silent, almost eternal. And then they will disappear too. Slowly, imperceptibly. Through unimaginable epochs, each black hole will begin to lose energy. Their event horizons will shrink. The last remnants of the mass will turn into radiation. And one day, in the infinite darkness, the last flashes will occur. The final traces of the objects that have governed the evolution of galaxies and the shape of the universe itself for billions of years. After that, space will become almost empty, without light, no stars, no galaxies, only infinite expanding space and rare particles drifting through absolute darkness. But while the era of black holes is still going on, somewhere in the depths of the universe, an ancient object is already moving, hidden in the intergalactic void. A black hole that survived the destruction of its galaxy and continues its journey through space. Silent, invisible, and so huge that next to it even galaxies look like only a faint flicker in the endless night of the universe.